you need a point. And I would always use point slope form unless they specify otherwise.
Okay.
Do you want us to do any of the others in 2 and 3 in that grouping or move on?
Um, yeah, can we do number 3?
Sure. All right, number 3. Same thing here. So the first part of the problem here, you're going to find the slope. It's 11 over 4 minus 2. Now, because I know already ahead of time we're going to have to make a common denominator, I'd like to just convert it to 8 over 4. And then we got 1/2 minus 0, just to kind of make this go a little faster.
Mm-hmm.
And then you multiply by the reciprocal. The less that you have to actually show steps wise, the easier. So there's your slope. Your slope is 3/2. This time the point that we ought to use is 0, 2. That's the b value. So this time I'm going to use y equals mx plus b because the slope is 3/2 and the b value is 2. You could use point slope form, but the b value makes it ideal for slope intercept form.
Okay.
Now, for the tangent line, you have to take a derivative. Everything we did up until now does not help towards the tangent line. Could you give me the derivative of this function, please?
Negative 2x plus 2.
And what is the x value that you should evaluate it at?
0.
0. So you're going to find f prime of 0. Negative 2 times 0 plus 2 ends up being 2. That's your slope. You're still going to use the point 0.02. So I would again use mx plus b for that.
Okay. Those ones are good then.
Okay. On to number 4. All right. Is that a negative in front?
Yeah, it's negative 1 over x plus 1.
Okay, fantastic. All right. The average rate of change, or the AROC, has nothing to do with calculus. They give you an A and a B. The average rate of change is f of b minus f of a over b minus a. So you have to evaluate the function at 1/2 minus 1 over 1/2 plus 1. I guess the instructor wants you to get like really good at fraction manipulation. 1 is really 2 over 2. That's how you get the 3/2. And then when you have a fraction on the bottom, you flip it to get negative 2/3. I mean, that's my guess. I don't really know why there's so much emphasis on fractions, but there is.
Mm-hmm.
F of 0 is negative 1 over 0 plus 1, which is negative 1. So your average rate of change in this problem is f of 1/2 minus f of 0 over 1/2 minus 0. That's why we did f of 1/2 and f of 0. So we're going to grab these values, put them into this formula here. Minus 2/3 minus a minus 1 over 1/2. The top becomes plus 1 or plus 3 over 3. The more you can just quickly think about it that way, write it that way, it becomes negative 2/3 plus 3 over 3, which is really 1/3 over 1/2. Whenever you have the same tops or the same bottoms, you can kind of manipulate this. This becomes 2 over 3 when you're done. Are you allowed to use a calculator in this part of the course?
Yep.
So you could, I mean, you don't have to do any of this. You can just go to the calculator and put in the numbers.
That is true.
But your teacher may or may not appreciate that. No. All right. Do you want us to do 5? Do you want us to move on? What would you like?
Um, yeah, I think we should do 5.
Sure. All right. Is that negative 1 over x plus 3?
Yeah.
All right. Okay, so same thing here. The average rate of change is f of minus 3/2 minus f of minus 2 over minus 3/2 minus a minus 2, like this. All right, so I guess the bigger challenge is putting in this into there. Do you have a calculator handy? Do you want to try calculating that one for us, please?
Yeah. Would that just be 1/1?
It is not. Are you, so the weighted entries calculator, -1 slash parentheses -3/2 plus 3 close parentheses,
Oh,
something like that. Got to be very careful. There's we'll call it implied in parentheses in the top and the bottom. They're there to make sure that well, they're implied, which means you're supposed to know they're there, but they're never written, which is frustrating. You have a new answer for us?
yeah, I got -1/3. I mean, sorry,
Negative,
2/3.
yeah, -2/3. So minus two is a little easier. Plus 3 is 1. That becomes -1. So it's minus a minus 1. On the bottom here, it's -3/2 plus 2. So maybe do 4/2 like that. Again, it's just a lot of fractions here.
Hmm.
The top is really -2/3 plus 3/3. You end up getting, again, 1/3 over 1/2, which becomes 2/3 when you're all done.
Hmm.
Any questions on that or feedback on that?
No, I'm good for that one. I realized where I made my mistake.
Okay. All right, on to 6 or 7 or both. Do you want one or the other? They're essentially the same.
Uh, just 6.
Okay, let's take a look at 6. So we've already done a couple of these. Tangent line at the given point. They've nicely given you both x and y. Sometimes they only give you x and you have to put it back in to get a y. You do have to take a derivative of this. Now, it looks more complicated. This is not quotient rule. It is power rule. That's just the rewrite of it. Can you tell me the derivative of this?
Yeah.
This exponent comes out in front.
Sorry, it would be 1/, uh x minus 3 squared.
Very good. I like the way you rewrote that. That is correct for the derivative. Now you put that -3 in for the derivative, that whatever that x value is, f prime of -3, 1 over -3 minus 3 squared is 1/36. It does not specify the equation of the tangent line. And so that means you generally want to go for point slope form. So you go with y minus 1/6 equals 1/36 x plus 3 for that.
Okay.
Any thoughts on that? Anything? I mean, it's kind of a standard thing to ask, but
So since those ones don't like specify, you could write it like that, but you could also write it like y equals, right?
mx plus b, yeah. It's a little more work though, because you got to actually then work it to solve for b. That's why this is preferred, because you have a point and the slope.
Okay. Then I'm good for those two.
All right, number 8. Number 8 here is concavity. Do you remember which derivative is concavity?
Second derivative.
Second derivative. So you got to find the first derivative, 3x squared plus 6x. Second derivative is 6x plus 6. Set it equal to 0. Can you tell me the possible inflection point?
Um, no, I don't think I can.
So you're just setting this equal to 0. I'm asking you to solve this equation.
Oh, okay. Then it would just be 6.
You're so subtract 6 from both sides. 6x equals -6. Divide by 6, -1.
Oh, okay, okay.
So that's, and I like to use a number line. I don't know what your instructor has you do in class, but you need to test points on either side of it. And I like to put the test points kind of away from it so that I don't accidentally think to use them. Um, you just need to pick something away from -1. 0 is always a good pick if you can. Don't have to get too crazy. -2. Do you remember where you're testing these from class? Maybe that was talked about.
Um, no, it's not that I remember now.
Okay, so you're testing them in the second derivative. And and
Oh, that's right. Sorry.
and I've labeled it here. I actually like to label it. I don't know if that's what you guys are doing, but I think that really helps. If you're putting 0 in for 6x plus 6, and what most students do is they get a number out, but you really only care whether it's positive or negative. It ends up being positive. Then you put in this other test point, -2, and for x, it ends up being negative. This tells you the concavity. This is concave down. This is concave up. So your final answer is typically presented where you say, okay, it's concave down from -infinity to -1.
And
Like
then
you can't,
concave up for -1 infinity.
yeah, you can't like leave this up to interpretation. You have to be very direct.
Hmm.
So if
All
you're
right, that was a
direct,
good refresher because we haven't done
yeah,
that in.
excellent. Okay. Um, 9. All right, so nine's completely different. We should probably do that one. You do get a mean value theorem on the AP exam, multiple choice, like pretty guaranteed to do that. Um, so first thing is you have to find f of b minus f of a over b minus a. So that's your a, that's your b. So you got to find f of 2 minus f of -1 over 2 minus the -1. So could you find either, just tell me which one. Do you want to find f of 2 or f of 1 for us?
Um, I'll do f of 2.
All right, let me know what you come up with.
All right. I'm just kind of lost.
So you're putting 2 in for x.
Oh, okay, okay. I'm so sorry. Hold on.
Yeah, you're just evaluating the function.
It's been a while since we've done these.
Yeah, take your time. I sometimes rush through the lessons unnecessarily.
Then it would be -6.
It is -6, and for f of -1, I got 0. This becomes -2 when you simplify it. All right, so that's not the answer, but that's the first part of it, okay? So
Mhm.
you have to remember to do this for the mean value theorem. Then you have to be able to take a derivative. Can you give me the derivative of uh of
It
this
would be
function, please?
it would be -3x plus 2x.
3x squared.
Sorry.
Yeah, plus 2x. Okay, and then you set this equal to -2. So you set it equal to that, and then you have to solve this, you have to solve this equation. Now, I would move everything to the right to make this a little bit more doable. So this becomes 3x squared minus 2x minus 2 equals 0. This one, unfortunately, you do have to use quadratic formula on.
Hmm.
Does that seem like your instructor style?
Yeah.
Okay, well, that's horrible.
Yeah.
All right, so you got to set it up, and then you just work it out. You typically do the b squared minus 4ac first, just to see if maybe it worked out nicely. That's minus 2 squared minus 4 times 3 times negative 2. This ends up being 4 plus 24, which is, I'm sorry, that's not right. That is right. Yeah, just 28. So that doesn't help. But it's minus b plus or minus the square root of that all over 2a.
All right, let me try to work that one out.
Okay.
All right, for that one, I got plus or minus, sorry, 1 plus or minus square root 7 over 3.
Like this.
No, like the whole thing is over 3.
Okay. So b though is I mean b though is negative 2. So it's 2, that part's okay. Plus or minus square root of 28 over 2 times a is 6. So you're right. Yeah, this is right. They would prefer, your teacher would prefer you write it this way, broken apart,
Oh,
probably.
okay.
But yeah, you got it. All right. Now, the thing is only one of these is in the interval from -1 to 2. So you got to figure out which one it is. Although they both could be in theory. So um it's not necessarily the positive one because it's, you got to kind of know, well, the magnitude of the numbers. Um, wow, this is actually tough to figure out without doing this. So the square root of 7 is like between 2 and 3. It's right. We'll just call it 2.5. So it's either 3.5 over 3, which is good, or it's negative 2.5 over 3, which is also good. So actually they're both good. Huh. They're both in the interval from -1 to 2.
Okay.
Wow. Teacher really went overboard on that one. All right. It's not gonna be like that on the AP. It takes too long to do that. All right, so 10, 11, 12. Okay. All right. Just keep going in order here. 10 sound good?
Yeah.
All right. What is the t value? It says t, it just say t greater than 0.
Yeah.
Okay. Okay, you guys are all right. So they want you to find the position function. The position function s of t is the antiderivative of v of t. It's this symbol right here. Have you guys seen that yet?
No, honestly, this is all kind of new.
Okay. So what they're trying to get you to do here is like, how do you go backwards from this? Like what should the position function be so that its derivative is this? So it's kind of like going backwards. Like, do you agree that the derivative of 121t is 121?
Yes.
So how could you get to 44t? So if there is a t squared, what would go in front?
22.
22. And then the last one's probably the most difficult. It is a t cubed. what's the derivative of t cubed
3t squared.
squared? Yeah, and then the thing is does that work? Um, well, you need a negative.
So is that like would that be the answer to the problem? Is that like all it is?
Almost. Well, almost. That's just sort of me guiding you through this. This is a terrible question. There's always what's called a constant of integration. And so that's why they give you what's called an initial condition right here.
Hmm.
And you use that to solve for C. So S of t is 0, and then you put 0 in for t. And you find that everything is 0. That's 0, 0 cubed is 0, 0 squared is 0 times 22, and so on. And so
Hmm.
C ends up being 0. So you might think, well, C is always 0, and that is not true. It just happened to be in this problem that the constant of integration is 0. So if you would like, I can give you a problem similar to this, but maybe easier to like help you work through this, or we can just say, you know what, I'm gonna figure it out later on. What would be best for you?
I think a problem to figure it out would be good.
Okay, let's say V of t is 12 e squared minus 6t. Okay, so what you want to figure out, and it's actually better if you write it up here. What's derivative? What is the original function so that its derivative is this line? It's usually easier to start with like the lower degree ones when you're first learning it. And
Hmm.
so the hint here is that it's e squared and a t cubed, but you might need to manipulate the coefficients.
Would it be 4t cubed minus 3t squared?
Yes, it would. Plus a constant, which we'll
Oh,
address at some point, but maybe
so
not
you
right
always have
now.
to write plus c, right?
Yes, exactly.
Okay. When we were given the answer key to this, he did not write plus c, but I thought it was one of those problems.
Well, it C ends up being 0, so that's why it's not included, but it's not always 0. Like meaning like it could be,
So if it
but
wasn't
not
0,
always.
would you have to write it or?
Yes, exactly. So that's where I would go a bit further, and I would tell you something like, let's just say S of 1 equals 2. Okay. So what that means is that 2 is equal to 4 times 1 cubed minus 3 times 1 squared plus C. This ends up being 2 equals 4 minus 3 plus C. You can see now that C ends up equaling 1.
Okay.
And then you'd have to put that back into this right here. You will be doing this later in the course. I have no idea why it's here. It's so out of scope. It's just terrible.
Yeah. Okay, then I think I'm good for that one.
Okay. All right. Let's talk about 11. 11 is a chain rule problem. So if we were looking at this like for the first time, I would tell you that to treat the inside function like it's a u, like
Hmm.
this. And so the derivative of of what's on the left here, y prime, the derivative of cosine. What's the derivative of cosine? Can you tell me?
Negative sign.
Negative sine u, but then you have to take the derivative of the inside function, which is u prime. That's the chain rule. The chain rule means you have to take the derivative of the inside function until you're done with inside functions. Now on the right here is u. This is kind of a problem. It actually is. u equal cosine of v, and v is really x squared. You kind of see how I'm piecing this together.
Yeah.
So the derivative of u prime is, well, the derivative of cosine is minus sine v times v prime, because there's an inside function.
Hmm.
So v prime is, what's the derivative of this?
2x.
2x. So now we can kind of start to back substitute. So u prime is minus sine v. Well, what is v? V is x squared. What is v prime? It's 2x. Notice in the original, we need u and u prime. We have u and now we have u prime. So if we bring all this stuff down, y prime is minus sine of u. U is cosine x squared. U prime is minus sine x squared 2x, like that. Just putting those pieces back and trying just to frame this better. There it is. That's a little better. So try to, you see where the u comes from. The u is cosine x squared. The u prime is all this. You can simplify. Does your teacher like you to simplify? Want you to?
I think he accepts both.
All right. Well, on the AP, they do want you to simplify so that you would get a positive, which you wouldn't even write. And so you would end up having this 2x in front. And then the order doesn't really matter, but you'd have sine cosine x squared times sine x squared, something like that. Or the sine x squared might be here.
Okay.
Do you want one like this to try? Maybe not as complicated, but just something like this.
No, I actually think I'm good for that one. I just need to make sure to simplify every time just so I can get into the habit of it before the AP.
Okay. All right. So 12 and 13 are actually more like 10, the stuff we're doing. They're just going like one step further. Do you want us to do one of them, both of them?
Yeah, let's do 12.
Okay. All right. I was kind of mentioning here, it's better to like V of t comes from A of t. Actually, this is not big enough here. Let's make this a little bigger, easier to read. So how do we get, what do we take the derivative of to get 46?
Like 46x.
The t in this case.
Oh,
Um,
yeah.
and how about what's the derivative to get to minus 6t?
It would be negative 3t squared.
Very good. Now they give you this initial condition because there is a plus c. So this time we actually do have to deal with that. They're giving you this initial condition here. So we'll do that. We'll do that down here. So negative 120 equals negative 3 times 0 squared plus 46 times 0 plus c. What is the value of c?
0.
This is 0. This is 0 squared times negative 3 is 0. 46 times 0 is 0. But c is equal to this.
Oh, sorry. I thought you like divided by it.
C is negative 120, and that does need to go back into this line here. I know it's weird to work kind of vertical, but this is a bad question. The way it's presented to you this early in the course. Now, they want you to find S of t, so it's the same idea. I would start with the constant. What the derivative of what gets you to minus 120?
Um, minus 120t.
Okay, and do the same thing for the 46.
23t squared.
23t squared. And then how about for the minus 3t squared?
Would it be negative t to the third?
Yes. All right. Plus C. And this time it says S of 0 equals 0, so you'll find that C ends up equaling 0.
Okay. Okay, yeah, that makes sense.
It's probably odd to do it this way, but I would actually like in that white space, I would have rewritten this at the bottom and I would still work them vertical until you get more comfortable with this. Because your progression is the derivative, derivative, derivative going down.
Okay, okay.
That's just a suggestion. All right, so I don't see like any in the grouping of like 13, 14, 15, 16. I just see the next problems are like 19 and 20, 18, 19, 20. Is that a mistake or do you need to see any of those?
No, for 14 and through 17, I was good for those. And I actually think I'm good for all of these. And I just wanted to see 20 again.
20, sure. Sounds good. All right, you'll have to tell me what is this xy cubed over here?
Yeah.
All right. So when you take a derivative implicitly, you assume that y is a function of x, which it already is, but you kind of have to say that out loud. And the idea is that whenever you take a derivative with respect to y, you treat it like x. You use the same rules as you do for x. It's 9 minus 9y squared, but you add in a dy dx.
Oh, it's one of
Whenever,
those problems.
yes, yes. Now, derivative of 3 is 0. The derivative of x is 1. I'm going to do xy cubed kind of off to the side here. It's really an FG situation, at least the first time. So the derivative of f is 1. The derivative of g is 3y squared dy dx. The reason I'm doing that is because it's a product rule. The derivative of this xy cubed is the product here. Is that familiar to you?
Yeah.
All right, so I really need to just make a little more room here. So it's x times 3y squared dy dx plus 1 times y cubed. All right, and just a little bit of simplifying here. You don't need the 0. On the right, it becomes 1 plus 3xy squared dy dx plus y cubed. Now the calculus is done. The rest is just manipulating the equation. So your goal here is to solve for dy dx, which means you have to get it on the same side, the other stuff not on the same side. You can move left or right. Generally, students move left. You're subtracting this whole thing here to get it left. And you can't combine it, you're just rewriting it.
Hmm.
So it becomes, and the order doesn't matter, minus 9y squared dy dx minus 3xy squared dy dx equals 1 plus y cubed. And now you factor out a dy dx. Minus 9y squared minus 3xy squared equals 1 plus y cubed. And then you divide both sides by what's inside parentheses. And that's your final answer. Sometimes you can simplify a little bit. This one does not really have that.
Right.
On the AP, this will be a multiple choice question, and they might have the signs, like they might factor out the negative and put it in front, and then these should be positive. They might factor out a 3y squared from both, or negative 3y squared. There's a few variations on how it would appear on the actual AP multiple choice. We could deal with that in April. It's November or October for another day. you want another implicit derivative, maybe to try on your own, something a little easier.
Do we actually go back and do number 13?
Sure. All right, is that v of 0 equals 0?
Yeah, I don't know why the printing was so bad.
That's okay. I just want to make sure. So same as before. Start with the constant on the right there, that's 16. What's the derivative? The derivative of what gets you to 16?
Int.
16t. How about for the minus 6t? What derivative of what
Uh,
gets you to that?
negative 3t squared.
Good. Plus c. When you try it, you're going to find that c equals 0 because 0, 0 squared minus 3 times 0 squared plus 16 times 0 is 0. So c ends up being 0. You do want to show that step. All right, and then s of t, and derivative of what gets you to 16t. And you should notice a pattern of like, oh, the exponents get bigger each time.
Yeah, 8t squared.
8t squared, perfect. How about for the next one?
Negative 3t. Sorry, negative t to the third.
Perfect, plus c. But again, you'll find that c equals 0 because minus 0 cubed plus 8 0 squared ends up being 0. Again, it gives you the wrong perception that it's always 0, which is not right. It will not be that, but that is what it keeps suggesting. Which is odd because your teacher's emphasizing these fractions earlier and like they're like really getting you off the hook on this. They're like not making this very difficult.
I
Yeah,
don't know.
don't get into the mind of another human. That's a bad place to be. So this is just me sort of speaking out loud my uncertainty about why it's this way.
It confuses
Uh,
me too.
all right, we got a little time left here. What else would you like us to work on tonight, if anything?
I actually think I'm good for everything we reviewed tonight.
I'll ask one more time just because there's a little bit. Are you sure there's not anything else you'd like us to work on?
Let me look through just in case.
Okay.
Yeah, no, I think I'm good for everything that we covered.
All right, I'll go ahead and stop here for